This is part 2 of the Chapter 4 Math podcast, and we're going to do exercise 10, 11, and 12, and I'm going to skip exercise 9. So the first one we're going to look at is Reverend Northwick climbs to the church belfry one morning to determine the height of the church. From an outside balcony, he drops the book and observes that it takes 2 seconds to strike the ground below. So he's looking at height. Height is a distance, so what we're going to be looking for here is the distance. We see that the change in time for this is 2 seconds for the object to fall to the ground. So we have distance, we have time, and we need to find, we're looking for distance, we have time. So for that information we're going to use distance equals 1/2 gt squared to do the equation, or to do the problem. Let's plug some numbers in here. 1/2 10 meters per second squared, and our time is 2 seconds, all that squared. We get whoop, we get 1/2 times 10 meters per second squared times 4 seconds, and that's going to be squared itself. This will cancel with that, so what we're left with is meters. So we have 1/2 times 10 is 5. 5 times 4 is 20. So our answer is going to be 20 meters. The answer to this is for B. Why would it be difficult to determine the height of the belfry if you dropped only one page? That comes down to that the page itself would be subject to friction. So it would float down, not fall down like a book would. Right, so let's look at the next one. This one is a question that's looking at hang time. So we have a ballerina who has a initial velocity of 1.8 meters per second. When she jumps up, she's going to reach a height, and at that height she's going to be standing still at the top, so her velocity at that point is going to be 0 meters per second. And we know that her we are trying to find the hang time. Now this hang time is going to be double what we determined in this equation, because what we're going to determine in the equation is how long it takes her to go up. We'll double that to find out how long it takes her to go up and to come down. So let's find our equation. We know that acceleration is equal to Vf minus Vi over delta t. Now we know this acceleration. The acceleration is going to equal g, which is going to equal to 10 meters per second squared. So let's plug 10 meters per second squared equals 0 meters per second minus, and now here's a mistake I made right here, is this is a negative if the acceleration is positive 10 meters per second squared in the downward direction, then going up would be negative 8 meters per second. So this is negative 1.8 meters per second. And if you subtract a negative number, it's like adding a positive. So we can do that. Delta t. So what we get here, what we're going to want to do is isolate the delta t. So we're going to multiply both sides by delta t and divide both sides by 10 meters per second squared. So what we're left with is delta t equals 0 plus 1.8 is 1.8 meters per second. This crosses out here and here. Divided by 10 meters per second squared. I'm sorry, this is meters per second. So that up. So this is meters per second. So we cross out this, we cross out this, and that right there. So we're left with is 1.8 over 10, 1 over 1 second. So our answer here would be 0.18 seconds. And once again, that's only for half the trip. That's just for going up. So our total hang time is going to be 0.36 seconds for the time to go up and to down. Okay, let's move on to number 12. What we have here is a seagull. What we have here is a seagull that's trying to drop a clam from a high surface, onto a hard surface to crack it open. So it's dropping it from a height of 25 meters. We know that it's going to fall to the ground, gravity at an acceleration of 10 meters per second squared. And what we're trying to find out is how long the clam is going to fall. So the equation we're going to use is d equals 1/2 gt squared. We're going to put 25 meters in for distance, 1/2 10 meters per second squared in for gravity, t squared. We're going to divide both sides by 1/2 10 meters per second squared. And they're going to cancel out. Divide this side by 1/2 10 meters per second squared. And if you look here, what we're left with is, move this over here, t squared equals 25 meters divided by 1/2 times 10 is 5 meters per second squared. We get rid of the meters, so what we're left with is t squared is equal to 25 divided by 5. So let's write that over here. T squared is equal to 5 seconds squared. 1 over 1 second squared is going to be second squared. When we find the square root of both those, we're going to get t is equal to 2.2 seconds squared. A second squared is seconds. So answer is 2.2 seconds.